Okay, guys, today we're going to talk about slope. Some common terms associated with slope are rate of change, rise over run, change in y over change in x, or unit rate. There are 4 different types of slopes. The first one, positive or increasing slope. In this one, the little piggy is saying, I wish there's an escalator. What a workout when the slope is positive. The next type of slope is negative or decreasing slope. In this one, the piggy's saying, whoa, this is easy when the slope is negative. Downhill, baby. The third type of slope is zero or constant slope. Life is fair on a level ground when the slope is zero. And finally, undefined slope. Wow, this is what they call a free fall. I feel weightless, at least for the moment, and it happens when the slope is undefined. This is an equation of a line in slope-intercept form. The slope is represented by the letter m, and that's the rate of change. The y-intercept is represented by the b, and that's when the x-axis is 0 and the line crosses the y-axis. Here's some vocabulary. Slope, rate of change, it's the steepness of the line. M represents the slope. Y-intercept, when the x-axis is 0 and the line crosses the y-axis, also known as the initial amount. And B represents the y-intercept, when the x-axis is 0 and the line crosses the y-axis. Slope of a line can be found by figuring the rise over the run. Here's a graph, and here's the slope of a line. You can figure the slope by finding 2 points on the line, as shown. Here's a point, here's a point. Now we're going to figure the rise. So we went up 2, which makes it positive 2, and now we have to travel over to the other dot, the other point, and we go to the right 2. So then our slope is 2 over 2, which equals 1. And then the same with this one. We found 2 points, and then we figured rise over run. Okay, now let's work on our first problem. The admission prices of a local water park are shown in the graph below. There are 2 payment options. Option number 1 is in red, and option number 2 is in blue. What we want to do is we want to describe the prices of both options. The best way to do that is in the form of an equation. So let's go back to the graph and let you look at it and see if you can come up with an equation for option 1 and option 2. Okay, you're going to have about 15 seconds to work on this. Remember, we're trying to find an equation for option 1 and option 2. You have 15 seconds. Okay, let's look at option 1 first. We start out with slope-intercept form. And then next, we know that the change, the rate of change, is 60 over 4, and that it crosses the y-axis at 0. Now the next step, all I did was I simplified 60 over 4, and I simplified it to 15 over 1. And notice that I did not put the plus 0. We really don't need that in the equation. Then the next step, I simplified the 15 over 1 to just 15. Okay, now let's look at option 2. Okay, option 2, if we look at our slope, we notice that it's just flat. That's what we called 0 or constant slope. So we put a 0 in place of our slope. It crosses the y-axis at 120. So then the next step, I just simplified. We don't need the 0 times x. So now y equals 120. So if we want to describe the prices of both options, option 1 is saying that at first, we don't have to pay anything. That's that plus 0, the y-intercept, the initial amount. We don't have to pay anything up front, but eventually it's going to be $15 for every visit. Option 2, up front, we pay $120. And that's the initial amount. That's where it crosses the y-axis. And then if you notice, the slope is 0. So that means that we pay $120 and we can visit the park as many times as we want. It's just $120. Okay, next question. If Joe were to go to the park 4 times in one season, which option would be least expensive? So now we're going to go back to the graph so you can look at it. We're going to give you about 15 seconds to look at it and decide. If Joe were to go to the park 4 times in one season, which option would be least expensive? Okay, guys, remember as you look at the graph, it's 4 times. All right, guys, time's up. Okay, there are several ways to solve this problem. The first way, solving by substitution using your equations. Option 1, it was y equals 15x. So all we're going to do is substitute our 4 visits, and we know that it's $15 for each visit. So 15 times 4 gives us $60. And remember, option 2, we just had a one-time fee of $120, and we can go as many times as we want. And then the next way of solving is going back to our graph and solving the problem from there. Okay, now using the graph, a lot of people will find this to be the easiest way. I just wanted to give you some options. So let's find on the x-axis, this is our visits, and we want to find 4 visits. So now we're going to follow it up until we hit the line for option 1, and then we're going to follow it over. And this is going to tell us how much it will cost for 4 visits. And that's the $60 that we got by solving the equation. I can do the same thing for option 2. I come back to the 4 visits and I follow the line all the way up until I hit option number 2, and I follow it over, and then I get $120. Alright guys, so now looking at both ways of solving by using an equation and by using the graph, it looks like option number 1 is the way to go. It's $60 and option 2 is $120. Okay, next question. During one season, how many visits would it take before both options are equal in total dollars spent? So remember, during one season, how many visits would it take before both options are equal in total dollars spent? Again, we're going to go back to the graph so you can look at it to solve the problem. We're going to give you 15 seconds. Okay, remember, as you're looking at the graph, we are looking to find how many visits it will take before both options are equal in price. You have 15 seconds. Again, there are several ways to solve this problem. The first way is to solve the problem by setting the equations equal to each other. So 120, that's option number 2, and 15x is option number 1, and we set them equal to each other. So now we need to solve for x. This is going to tell us how many visits that they will have to visit for them to be equal in price. So all I did was I divided by 15, and then 20 divided by 15 is 8. It will take 8 visits, and then they are both equal in price. The next way to solve this is solved by using the graph. So let's refer back to the graph. Oops, I noticed that I made a mistake. This was 120 is equal to 15x. And when we come down to this next step, it is 120 divided by 15 will give you 8. And it's 8 visits that are required before they're both equal in price. Now, let's go back to that graph. Okay, this time, we're going to look where the two options intersect. So now we find this point. And remember, we're looking for the number of visits it will take when they're both equal in price. So I'm going to be looking for the x-axis. I'm going to follow it down. And then I get 8 visits. It will take 8 visits for them to be equal in price. Okay guys, what I do want you to notice is that anything before that intersection, option 1 was the cheapest. And then anything after that intersection that we just spoke about, option 2 is going to be the cheapest. All right, last question. How much money would be saved from purchasing a season pass if Joe visited the park on 12 occasions during one season? Teachers, at this time, you can pause the video and allow students time to work this problem. Okay. We know that option 2 is $120 no matter what. That was our initial cost, and we don't have to pay any more for option 2. Let's see how much it'll cost for 12 visits using the equation for option 1. Remember, option 1 was y equals 15x. That means it's $15 for every visit. We substituted the $12, the 12 visits. 15 times 12 is 180. So it will cost $180 for 12 visits using option 1. Option 1 will cost $180 for 12 visits, and option 2 is $120, and you can go as many times as you want. Looks like option 2 is the better deal for 12 visits. Looking at the graph, as you remember, where the lines intersect is where the two options